And it's go time. Hello, 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 ladies and gentlemen. Boys and girls, welcome to VUX World. I think this episode. I had a look the other day. I don't usually count episodes, but it's something like 235 or something like that. So it's been going for quite some time now. And today's guest, I'm delighted to welcome Peter Voss, who is the CEO of Aigo. Going to get into a really good conversation all about essentially a different way of modeling language, I suppose. Would you say that, Peter? I'm assuming it's a lot further than, a lot deeper than that. But
Yeah, it's conversational AI, but really ultimately it's about human level artificial intelligence, yes.
exactly, human level artificial intelligence. Was, there was a post, I forget, forgive me, it might have been Jim Robot actually that might have posted something on LinkedIn to the effect of something like what will it when will conversational AI be truly human like? And a response I had to that was human like is one thing, but kind of like passing off for a human is something totally different. And my kind of point was that we don't necessarily fully understand the ins and outs of the human brain, and language goes so deep into the constructs of our brain that in order to explain or understand properly uh, language and context and memory and all of this kind of stuff, you keep scratching the onion, and eventually you get to like consciousness
hmm
itself, sort of thing. So my kind of point was that I don't know if we'll ever get there, but I think you've probably got a different idea than that. And so I'm definitely keen. Maybe we'll kick off with that in 1 second. But before we do, I want to give a shout out to Core AI for presenting VUX World at Voice 2022. The Voice Summit is back in October from the 10th to the 12th of October in Arlington, Virginia. And VUX World is running a conference within that conference. We've got the whole room to ourselves, the whole stage all day long on the 11th. And we're going to be focusing exclusively on contact center automation. So if you are looking for ways of automating your contact center, if you're looking for best practice, if you're looking for the right kind of tools, the right kind of resources, the right kind of processes and practices to be able to bring a really effective customer experience to your call center, then this is the event for you. It's going to be practical deep dives into all kinds of case studies. We've got Core AI there, we've got Cognigy there, we've got Vonage and Ericsson there, we've got Poly AI and Landry's there. We've got a whole bunch of really interesting companies doing some really interesting work, and we're going to be sharing how to do it and how you can do it at Voice Summit. And you can save 20% on your tickets right now by using the promo code VUX20. So go to voicesummit.ai, promo code VUX20, save 20% off your tickets, and we'll see you in Arlington, Virginia. And very finally, next week, I'm running a workshop in partnership with Cognigy where we're going to be assessing your level of CX maturity and helping you devise a plan of action to up your game as far as CX is concerned. Some of the best teams in the business, you will learn from them. You'll be able to network with other CX professionals. You'll be able to figure out where you sit on the CX maturity scale and what kind of things can you do within the next kind of couple of months to start building your team's CX maturity to deliver better customer experiences for your customers. It's on September the 1st. All of the details to that will be in the show notes. But if you're listening on the podcast, you can go to vux.world/Cognigy. That is COGNIGY. Cool. So, as I was saying, uh, my kind of response to Jim Rowe's question was that I'm not sure whether or not, and I could be wrong, whether we fully understand the human brain to a level where we can um, replicate it, so to speak, in order to create an AI which has consciousness, which has a full, complex understanding of language, can manage the same kind of things that we do long term memory, short term memory, context, and a whole bunch of other things like that. But then I found that Igor is kind of, correct me if I'm wrong, but almost doing that. Is that right?
That's right. We have a chatbot with a brain, and
Right.
as opposed to all the other chatbots that don't have a brain. So, of course, brain is a metaphor here. You're right. We don't really fully understand how the human brain works. But I think we have enough understanding of how the human mind works and how what intelligence entails, and how to yeah, what language is about and how one can build a system that can have an intelligent conversation, that can think and learn and reason the way humans do. You know, the analogy we often use is we've had flying machines for over 100 years, but we still nowhere near reverse engineering a bird.
Mm.
And I think it's similar. We're not trying to reverse engineer the human brain as such, but we want to understand, and I think we do already have a lot of understanding of what mental processes are. And I think we can build machines that replicate human mental processes and give us intelligence. Now, we're not at a level of human level cognition, you know, an IQ of 100. But I think the fundamental mechanisms for cognition, you know, for reasoning, for learning, for memory, for context, and so on, we have, we have certainly already built that, and we can see a path of how to get that to human level.
Very interesting. And you've got a load of experience with this, 20 years plus, part of the team that coined the term artificial general intelligence, which is becoming incredibly well used now, given
Mm.
that we've got a lot of technological progress over the last few years with large language models and things like that. Technology where is now leading people to believe that there is something else behind it, not just the ability to recognize a pattern in a sentence and respond with something, but actually the ability for the machine to at least seem as though it's thinking. You look at some of the Lambda 2 examples from Google recently and the Palm language model and some of OpenAI's stuff, and it's like, Cohere, and there's just so much progress happening that it's getting to a point where, it would be common, I would say, for some people to interact with one of these systems and believe that it is either another person or super intelligence thing behind it or whatever it might be. Like, is what do you think has kind of changed over since maybe you started Aigo, or maybe it's even just before that, or in the last 20 years since you've been working in this? What differences are present now that enable you to be able to build something that you could call intelligent?
So I don't obviously over the last 20 years, computing power has increased significantly. You know, the amount of computing power that we have on a normal laptop computer, the amount of memory and so on. So that's very helpful. Now, the kind of language models that you're talking about that are now making the news, you know, like GPT-3 and so on, they are relying very heavily on this massive increase of computing power and the amount of data that's been collected. They are really brute force statistical systems, and you know, somebody called them stochastic parrots. So
Mm.
I think one needs to be careful about the appearance of intelligence and actual intelligence. Now, it's not always easy to sort of discern the difference, because if you're interacting with one of these massive language models that, you know, have zillions of conversations basically in memory, and you say something and they respond, you know, quite intelligently to it because they have that in memory somehow, and the way they put it together and the way they can kind of seamlessly continue to have a conversation is quite impressive. But it's also very easy to find out that they don't know what they're talking about. There is no reasoning. There's nobody at home. You know, it's they kind of regurgitating intelligent bits of information in a way that's actually very impressive. But it's totally unreliable. You know, you can say the same thing to them and they'll answer differently. You can give them counterfactuals and they'll agree with you, and they're all over the place in terms of actual, you know, factual understanding. So there is really no reasoning behind it. So they appear intelligent, but they are not. They are not intelligent. And so my own opinion is that it's kind of a massive distraction to go down that road and not really address what intelligence truly requires to, and to build systems that address the requirements of intelligence. And that would, for one, require deep understanding, or require the ability to learn on the fly and to remember that. And most importantly, to be able to reason, and even to reason about your reasoning. And these systems can't do that. And it's hard to see that they can be extended to do that.
Interesting. Yeah, they are very much. They just seem like kind of like pattern matching systems, don't they? Which is, I think there's a very high degree of novelty at the minute, which is, isn't it novel to just
Mhm.
kind of like give it a title of a book and have it generate 50 other titles of a book, or give it a instruction for a picture and have it paint
Mhm.
a picture. It's kind of like novel a little bit, but you can see that it's very much. I kind of compare it, I suppose, a little bit to um, Amazon Alexa when it was kind of first
Mhm.
released, which is that you say something and you get a response, and that's what most of the Amazon Alexa use cases were: request, response, request, response, request, response, isolated requests, isolated
Correct.
responses, not conversational.
Correct.
And that's kind of what they're a bit like, isn't it? Give me a book title, give me a picture of a Dalek shooting the sun
Mhm.
down or whatever. Um, so what is what is intelligence then? If those aren't intelligence, if that's just really matching a pattern in a sentence and understanding, broadly speaking, what output goes with that input, you kind of alluded to what intelligence is there. What do you class as intelligence?
Yeah. So intelligence is ultimately to be able to learn to deal with novel problems, let's call them problems, or novel situations, and the ability to learn interactively in real time is a key requirement. But that also implies that there is a deep understanding of the situation to be able to, to learn and come up with solutions to novel problems that you haven't come across before. Um, so there are these requirements of intelligence. I mean, to give you one example here, that if you hired a personal assistant, a human, to help you with your life, and that person didn't remember what you said 2 sentences ago, or what you said yesterday or the week before, they wouldn't last very long.
Mm.
Or if they just, to the same response would to the same request would just give you a totally different response as the current systems do. So you require learning in real time. You require deep understanding, and you require reasoning. That's part and parcel of understanding. Does this actually make sense? What does it mean? What are the implications? Um, and those are all requirements of intelligence. And so an intelligent, artificially intelligent system needs to have the ability to needs to have these capabilities basically as part and parcel of it.
Mm. So where do you start with that then? So because that's what a lot of the sort of like large language models, I suppose, are attempting to display in some cases,
Mhm.
dealing with novel problems, questions that haven't necessarily been hard coded as that we expect this question and here's the response kind of thing. It's almost like here's a pattern that exists within this query, and
Mhm.
using a big, huge knowledge base that we've built from billions of words or parameters,
Right.
we can estimate a response to that. Is that not dealing with novel problems, or is that a
N-
dumb way of doing it because you don't really
No,
understand it?
because they can't do anything outside of the domains of what the training set was, and they don't reason about the responses that they give. There's no understanding in the the sense that we mean understanding. They don't really have a model of the world, and so they can't reason about it. It is really simply a statistical response. So it's sort of like flow of consciousness or something that you might be dreaming, which doesn't necessarily make any sense, and that that's really how these models work right now. And the leaders in the field are very aware of that now and becoming increasingly, especially in the last year or so, and they're talking more and more about the fundamental shortcoming, which is, I think, identified as the lack of reasoning. That's kind of one way to capture it, because reasoning implies deep understanding. And they're talking about hybrid models. So how can we bring symbolic reasoning and symbolic processing, and they talk about hybrid models, but it's at the moment very exploratory. It's more identifying that there is a problem without actually having solutions to that problem. Now, another thing that I think isn't recognized nearly well enough is the ability to learn interactively, to learn new things, new facts interactively. These models have to be trained with massive computational resources, and the model is then trained and it's essentially fixed. You really need an intelligent system, needs to be able to learn completely new things. For example, you wouldn't have a GPT-3 model. It couldn't learn how to play chess if you told it, or some novel game or whatever. So the ability to actually learn through interaction or through explanation is completely missing. There isn't that kind of ability to learn in real time, and to then have that as part of the knowledge base that you have. They really aren't models of the world, and reasoning is missing. So there are a lot of components missing that are really required for true intelligence.
Where did you first recognize that? Like, what was the point when you thought, I think we need to do something with Aigo here, because here's the problems that we're identifying? When was that, when you first kind of started to realize this stuff?
Right. Well, it's actually long before Aigo. So my background was, I actually started out in electronics as an electronics engineer. Started my own electronics company. Then I fell in love with software, and my company turned into a software company. I developed a sort of comprehensive ERP system. We became quite successful. So when I exited the company, I thought, how can we make software more intelligent? Because what struck me is, even I was very proud of the software that we developed, but still it's dumb. If the programmer didn't think of something, it would just crash or give you some error message or something. So how can we build intelligent systems? And it took a long time. I took off 5 years to study intelligence, all different aspects of intelligence, to really deeply understand what intelligence entails in order to build systems that have intelligence. And so I studied epistemology, theory of knowledge, to really understand what is reality, what is knowledge, how can we be sure of how can we be certain of things. I studied cognitive psychology and developmental psychology. How do children learn? What's the difference between animal intelligence and human intelligence? So I really went through all of the different aspects of intelligence, and that was some 20 years ago. And I realized that you really need a cognitive engine. You need a cognitive architecture that has all of the elements required for intelligence. So it has the elements required for reasoning, for concept formation, for memory, long-term memory, short-term memory, context, deep understanding, metacognition, thinking about thinking, and so on. You really need a system that has all of these components. And that's basically, we started architecting that. And then in 2002, as you mentioned, I coined the term AGI, artificial general intelligence, together with two others, because we realized that pretty much everything in the field of AI didn't actually address what intelligence requires. The field of AI had gone from 60 odd years ago to build systems that can think and learn and reason the way humans do. That was the original dream and the intent, the goal of AI. But of course, that turned out to be incredibly difficult. So what happened to the field of AI? It turned into a field of narrow AI to basically solve one particular problem at a time, whether it's container optimization or some specific medical diagnosis, or when we had the breakthrough of Deep Blue becoming the world chess champion, and so on, and now more recently, the Go world champion. But these are narrow AI problems, and there's an important element here is not only are they narrow problems that you solve one problem at a time, but the more important thing is that the intelligence is really external. It's the intelligence of the programmer or the data scientist who figures out how to use computer technology to solve that particular problem. What algorithms do we need, or what models do we need? What data sets do we need? How do we prepare the data? How do we tweak the parameters? How do we actually get this thing to solve the particular problem we're trying to solve? And so that's narrow AI, and we basically, myself and a few other people, have sort of come to a point to say we really want to get back to the original dream, to the original vision of AI, to build thinking machines. And so that's why we need a different term to differentiate ourselves, from the mainstream AI, and that's why we coined the term AGI, artificial general intelligence. And so, yeah, it's nice to hear that the term has taken off, but we've taken a bit of a detour with these big deep learning, machine learning, these big data systems that have become so incredibly powerful and so impressive in so many areas, but they really don't address the requirements of intelligence.
That's a really interesting summary. So would you say that Aigo is an AGI, artificial
I,
general intelligence,
I
or
would
not?
call it a proto AGI because AGI sort of in my mind implies human level intelligence, and we are nowhere near. I mean, if I had to kind of put a value on it, I'd say, if Alexa and Siri have an IQ of 15, we're at 30 or something, 35 or something. So we're still a long way from human level intelligence, but the fundamental architecture that we started working on this in 2002 when I started my first AI company, and we spent several years in R&D mode, basically just taking these ideas that I'd come up with and turning them into actual code. And then we started commercializing this in 2008 in the call center space, a company called Smart Action, using a brain, cognitive architecture, using this proto-AGI brain. And we've since basically been alternating between development phases and commercialization, and keep moving closer and closer to human level intelligence. So I believe we have the right architecture to achieve that, but there's just a lot of work to be done. And one of the big challenges is that as humans, we just have such an incredible amount of common sense knowledge that we just acquire by growing up in the real world, that a disembodied AI or AGI, proto AGI, simply doesn't have that experience, doesn't grow up in the real world. So to give it that knowledge is quite challenging. It's just a big exercise, and will take quite a lot of effort to achieve. So there are the mechanisms to be developed on the one hand, and then on the other hand, to give it the knowledge that's required, that broad knowledge, common sense knowledge, and the common sense reasoning that follows with that. And that's kind of our biggest challenge right now.
Mm. So would you say then that you have the kind of framework, which is the brain and the structure and the foundations, but not necessarily, because one of the things I posted something actually last week or the week before, which was the two
Hmm.
things that are failing the voice assistants that we know of at the
Hmm.
moment, and one of those things is fulfillment. So even though Amazon Alexa, Google Assistant, etc., may work on that intent-based model of just what is it that you want and now let's fulfill it. In order to fulfill that, for it to be a generalized assistant, it needs to be able to do lots and lots and lots of things. It's not just play music and set timers, but it needs to organize for me and you to set an appointment in the diary and make sure there's a Google Meet link in there, or it needs to be able to, you know, whatever it might be, do your shopping for you, or arrange for someone to pick your kids up from school, or check if the babysitter's
Right.
available, or add a note. Add a note to Evernote is something so simple, but that's something that would be a killer feature for me. So,
Mm.
but it needs to do a load of stuff, doesn't it?
Mm.
And part of the issue is that if I ask Alexa to check my bank balance, it's not going to do that because my bank hasn't exposed itself to Amazon, hasn't created an Alexa skill, doesn't have APIs that are interrogatable from via that platform. So the gap or the massive challenge is for these assistants to be able to fulfill the breadth of things that people need them to do. Is that the same challenge you're facing now that you have the kind of framework of the brain, or is that not really the challenge? What's the main thing?
Yes, that's certainly a big challenge. Now, you mentioned, for example, logging onto the bank and getting bank details. Now, of course, an AGI would be able to do that even if the bank didn't provide the APIs in the same way that humans do it by, looking, going to the website and logging on and clicking and so on. And you would need to have you need to develop the interfaces to basically to be able to manipulate websites and to make sense of what you're seeing, which is actually something we experimented with, some 20 years ago, to actually build an assistant that could interact. It would have additional sensors that would basically be a mouse and a browser sense, that it could use a mouse and use a browser and see what's happening on that. It's quite a challenging project, and we didn't pursue that because the sort of low hanging fruit were um, call center automation, and we that's what we focused on. But having the cognitive mechanisms, you can then again the system should be able to learn all of the different skills to do that. It's just there's a lot to learn, and even though billions or trillions are being spent on deep learning, machine learning, they don't have the right architecture to ultimately give you this general intelligence. And there aren't enough people working on cognitive architectures that are required to give you this ability to have a personal assistant, and to gain this knowledge, this common sense knowledge that you ultimately need for an effective assistant. So we are, slowly building out the repertoire of skills that the system has, and we obviously trying very hard to accelerate that process so that we can increase the capabilities of the system. Right now, we are working with specific large enterprise companies where the system really only has to know about their particular domain. So we only have to give it the knowledge base of that domain, which is a lot more tractable than a general personal assistant that we might want to use, where you might want to know about your sports scores, or help you travel, help you plan a trip with all the complexities that you have there, and as you say, banking and whatnot. They're just and a lot of different domains you would need to have knowledge of and ability to interact with.
Hmm. So is that then kind of taking that AGI, because earlier on you mentioned that there was the concept of AGI and then AI went more into like specific narrow
Mm.
domains. It sounds as though, correct me if I'm wrong, but that's kind of your approach has been to go into the enterprise, focus in call centers. That's kind of a narrow domain, but I suppose the difference would be that you're not necessarily, and I don't want to put words in your mouth, but is it that you don't really care about the domain necessarily, it's the brain that is the thing that you've kind of built, which is the kind of secret sauce sort of thing, the golden ticket kind of thing, and you apply that to any domain you like, or have you actually took a conscious effort to go and try and focus in particular domains like healthcare or banking or whatever it might be, in order to, I don't know, round out
Mm.
the features that you have, or take it to the next level, or what have you?
Yeah, no, you're exactly right that our technology is domain agnostic. So, and we are actually doing applications in medical applications. We're doing banking. We're doing retail, and we are sales assistant. I mean, all sorts of different applications. And the interesting thing is using the using the same brain. It's just that you then need to teach it the specific domain knowledge to be able to handle that. It's just we can't boil the ocean and give it all the knowledge that it requires to be sort of a personal assistant, but we're obviously trying to grow into that. And we want to get to a point where the system can learn by itself to a large extent, where it just needs less and less human assistant to be able to learn new domains. So some of the experiments we did is to have Aigo go to Wikipedia and learn from Wikipedia, read a Wikipedia article and extract knowledge and be able to have that knowledge in a usable format. And we could do that to a limited extent, but we need to climb up the IQ ladder a bit more for that for that to become viable. At the moment, it still requires too much human interaction, where basically is reading this Wikipedia article requires additional background information to even make sense of it. So it's kind of a bootstrapping requirement, and we're hoping to get to the point where it requires minimal human explanation and assistant to be able for the system to be able to learn by itself. So that would be one of the sort of major milestones where it becomes a lot simpler for it to acquire new knowledge.
Mm. And would that be something that would be a repeatable part of the brain, as you mentioned? You can apply the brain to any different industry or content or whatever it might
Mm-hmm.
be. It's the brain itself which is the thing. Would that be part of that initial core framework, or this whole self-learning thing?
Mm-hmm.
Would that be dependent on the use case or the industry? Because I'm assuming that, if it comes across something, if you're working with a retailer
Mm-hmm.
and somebody says something to it that it's never come across before, doesn't really know what to do with,
Mm-hmm.
but hears that enough times that it then, however it does it, figures out that this is something I need to learn. At the moment, that kind of happens with
Mm-hmm.
things that people say to it that get like a no match or whatever it might be. That'll go to a person. It'll then be categorized and classified and put into some trading data. A new intent will be created or something like that. And it seems as though you're kind of talking about something similar might happen, but it would be automated. So would that be something that would be a core part of the framework, or would that need to be created and tuned for every individual domain or
Right.
use case?
So a couple of considerations. So yes, ideally, what we want and what we're working towards, where when Aigo doesn't know something, think of it as a call center agent and an operator in a call center, in the same way that they get a query from a customer that they can't answer. So what do? If they're diligent, they would ask their supervisor, or they would ask somebody, is how do I answer that question? And if they really wanted to deeply understand, if they sort of want to make a career of this, they would not only want to understand how do I answer this question, but why do I answer it that way, and what other background knowledge do I need to know to really understand fully what that situation is. Do you ship internationally? And there might be a whole lot of complexities of it, that depend on different things, that certain products you can do internationally and others you can't, and which countries, and how this affects shipping charges and whatnot. So there might be a whole lot of additional knowledge that you need to gain, but to get this into either to be able to look it up on the website or whatever, or to ask somebody. So that's kind of the point we'd like to get to in commercial applications where Aigo would know what it doesn't know, and then to actually be able to interactively ask questions and get the information, rather than what you're saying, the way it's kind of done now is that people go through logs or have some tools that will basically say what things couldn't the system answer, and then you give it additional training basically, and that's a whole sort of new uh, manual process. So yes, if the system has enough intelligence, it would be able to learn the way a human agent would be able to learn, fill in the gaps in their knowledge.
Mm, interesting. You mentioned one thing that constitutes intelligence is the ability to reason. So, how do you create an artificial intelligence that can reason without any kind of manual intervention, so to speak? Like the way that most chatbots, for example, or voice assistants would reason nowadays, is there is some kind of state management kind of component which gets information from the NLU, which says this is this intent,
Mhm.
and it's this confidence, and if it's not as confident as we want it to be, we will then go back and clarify, or we can disambiguate, or it gets to, this intent means that when this certain slots have been filled, then next we do this. So you almost like
Mm.
build like almost like a conversational map, like a business process kind
Mm.
of thing that tells it what to go where and what to do. I suppose that's a little bit of what you would call reasoning, perhaps, but it is very much hard coded and done manually for every conversation. What's the difference between, or how you're, is that how you're describing reasoning, or what's the difference between the
No,
reasoning component?
not really. I mean, there are overlapping components, of course, in terms of, reasoning entails such things. I mean, first of all, you have to have deep parsing, which the chatbots without a brain don't have. I mean, they don't actually try to parse a sentence and get every component of the sentence. They basically just feed the utterance into a categorizer, and then the categorizer will spit out which intent triggered. And if it's a bit more sophisticated, you might even have more than one intent trigger with different strengths, and then
Mm.
you can go with that. No, here we're talking about having a deep pass to start off with, but that pass by itself has to already involve reasoning. So, for example, it has to be able to disambiguate if there are ambiguous terms in there. When you're talking about, um, taking again a commercial example, the gift for my daughter. So, what gift are you talking about? Um, so the system would have in memory, presumably, or would have access to it. There may be multiple gifts, and there's a gift to the daughter. Now, which daughter? So reasoning system would then know what gift you're talking about, if that knowledge is in memory, and it would also know which daughter if there was more than one daughter, because the two would map up. So that would be part of the sort of the reasoning process. But there are also implications that are part of reasoning. For example, what is possible and what isn't possible. So, for example, what's in the past and what is in the future is something. If the birthday has already passed, you can't still deliver it in time for the birthday.
Mm.
Uh, so all of those things are part of reasoning, and of course, specific examples. If you give one specific example, you can always write some code to do that. And sophisticated chatbots write a lot of specialized code to deal with all sorts of different situations. If you're trying to, book a flight or whatever. But what we're talking about is the general mechanism of being able to reason. So to take what you're hearing together with the context of the conversation, where are you, what are you trying to achieve, what is the current goal or the sub goal, what goals have already been achieved, um, what do you have in long-term memory, what are realistic of constraints of reality. All of those things need to be taken into account for practical reasoning as we do.
Mm-hmm.
So that's what I mean by reasoning, is that the engine itself, the intelligence engine, has the mechanisms to be able to reason using context, using memory, using deep parsing, and constraints of reality.
Interesting. You mentioned IQ a few times over the
Mm.
course of the conversation, and I suppose everything that we're talking about here, for those tuning in at home, might be a bit conceptual. How do you kind of, for example, Aigo, let's say that you take, I know, 1-800-Flowers, for example. Let's say you take that instance of, is it a chatbot for 1-800-Flowers? Is it a call center?
Yeah, they're using Aigo for their chatbot
Chatbot.
support.
Yeah.
Hmm.
So let's say that we
We
take.
we call it a chatbot with a brain to kind of
Yeah.
differentiate it.
Yeah. Well, I like the term digital assistant more than or AI
Yeah,
assistant or something like that because it makes it sound, it's more
yeah,
helpful. The bot sounds a bit dumb and it's got a
yes,
hangover from the keyword
that's
stuff.
right. Yeah.
Yeah. So let's say you take your the assistant for 1-800-Flowers.
Mm-hmm.
You take another assistant from somewhere else. Name any other company with any other chatbot.
Mm-hmm.
How does how do you kind of measure the intelligence of the two? Do you use IQ? You mentioned IQ a few times. Do you use IQ? Is that a good measure
Well,
for
no,
intelligence or not?
IQ is that is really just sort of an abstract way of looking at it. No, IQ tests don't really apply here, and with whatever the difficulties are of IQ tests are anyway. I mean, first of all, an AI system could be specifically trained to be good at IQ tests.
Mm,
Um, so no, we don't use IQ tests, but for commercial applications. Conversational AI, it's typically very, very easy because you have essentially containment. You know, what percentage of conversations that normally a human would need to handle are automated in a satisfactory way. So that is the simplest measure. And, so if a dumb chatbot can do 20% and an intelligent one can do 60%, then it's a very, very obvious difference,
mm,
and also, of course, the quality, customer satisfaction, and so on, can be taken into it. But containment, and I hate the term containment because it's such a
mm,
negative term. It's always how can we deflect things from human agents? And I'd like to just say a few words here, which I'm sure your listeners will appreciate and be aware of as well, is automating a call should not be inferior to a human handling it. In fact, it should be the opposite. Because you have no wait, there's no wait time, even in busy periods. Secondly, an intelligent chatbot should already know a lot about you, unlike a human agent who doesn't really have the time to look up all your history and so on. So, for example, if you were dealing with your cable company, your internet provider or whatever, and you talk to an assistant, a digital assistant, it should remember that you called yesterday and you've already tried rebooting your modem 3 times, and also that you tried moving it into the kitchen to see if you'd get better reception. So now, next day, you contact it, and it's as if you are talking to a technician who remembers the conversation exactly that you had yesterday, which is not going to happen with a human,
mm,
and can then give you this hyper personalized experience, and assistant. So um, an automated assistant should actually be much better than a human agent.
mm,
Now, that's assuming it has the skills and the intelligence to handle the particular domain that you have.
Yeah, definitely. I definitely agree with that, without a doubt. It's interesting because the whole concept of contain, I hate that word myself as well, containment. In fact, I think I wrote something about that a few years ago, which is why I think it was called something like why you shouldn't use containment, and it was
Mhm.
mainly just getting at exactly what you just said, which is it's a bit of a negative connotation, and really it should be about servicing people rather than containing them. But a question I always ask is how how do you, because containment may be positive or negative, mightn't it? It may be that a user is contained and they're just circling around and can't get an answer to whatever they're trying to do, can't accomplish
Right,
what they're
right.
trying to do, and then just leave. Or containment might be they get everything right and everything's done and everyone walks away happy. So I always ask, and there's different ways of measuring this. Some people don't measure it, and they'll say, well, there must be a good enough accuracy within 1,000 people that are contained.
Mm.
There must be a good enough accuracy in there, otherwise everyone would be complaining about it. Others might have like manual based like follow up questions, like did that answer your question, yes or no.
Right.
Others might tag certain intents or certain responses and stuff like that. I'm always curious just to learn a little bit about how do you drill into this containment metric, and do you do anything under
Mm.
that to try and establish this was success and that wasn't, sort of thing?
Oh, absolutely. Yeah, I mean, a key part of it is, I mean, we definitely measure the difference between containment in sort of the sense of, well, they they didn't get through to an agent, so it was contained, but they may just well have given up and abandoned it versus achieving goals. So our systems are all goal oriented. So you obviously identify what is the ultimate goal of the person contacting you, and or goals if there are multiple goals, and did you fulfill the goal? Did we actually end up fulfilling the goal? And that we know in the conversation whether it reached those milestones, and that is how success needs to be measured. The other thing that we try to persuade our customers, if they need persuasion, is to make it easy to get to a live agent. So I mean that makes for a good customer experience, that it's not this sort of negative containment. You're trying to make it as hard as possible to get to a live agent. No, it should be the opposite. If the automation can't cope with it, or the person simply doesn't like dealing with computers, for whatever reason, uh, to make it easy, but that the experience is so good that even somebody who says, I always press zero, to get to an operator, that the experience is so good that they, making progress and getting results, and they feel they're getting making progress, that they actually stay with the digital assistant instead of pressing zero.
Mm.
So that's the kind of experience you want to give. But you're totally right. You don't want to measure just did you contain it? Did you prevent it from going to a live agent? You really want to measure, was the self-service successful?
Mm. Mm.
Did the customer achieve whatever goal they had?
Yeah. And part of something being intelligent, I would say, is the ability for it to, for example, if I was to send you an email, you would be able to respond to that email. If I was to speak to you on the phone or over a video call like I am now, you understand that and you can respond accordingly. If I was to send you a text message, you would also respond
Mhm.
to that. As a human, you can receive so many inputs, and that's just language-based inputs. If I frown
Mhm.
like that, then you'll pick up on something that I might
Mhm.
not be happy about. If I'm smiling, then you pick up on that. There's
Mhm.
all kinds of different inputs that an intelligent sort of being, so to speak, can take and
Right.
interpret. Um, Maybe we'll start with the voice channel, but then I'd be interested in getting your thoughts on other modalities as far as input and outputs are concerned. But maybe first, we've mentioned chatbot, you've also mentioned call center.
Mhm.
On the voice side, how do you kind of handle that? Do you have like proprietary speech recognition tools? Do you use off the shelf kind of ones, and you focus on the engine? Like, how do you approach the voice channel?
Right. So you actually make a good point with omni-channel. People talk about omni-channel, but by having a brain that is the center, that same brain is actually used irrespective of the channel. So whether it's voice or or text or Apple Business Chat or on the website or whatever. And you can really transition the conversation from one channel to the other channel because it's the same brain handling it. But yes, as far as voice is concerned, we have our own speech engine. And it's actually important not to use just an off-the-shelf speech engine because you want your speech engine to be deeply integrated with the brain. So that, and we are actually with Aigo, we are just in the process of commercializing speech. Up to now, we actually only had text. We are in the final stages of building speech engine. But in my previous company, Smart Action, which was specifically speech focused, we originally used the Nuance engine, but we got better performance out of Nuance than Nuance themselves got. And the reason being is we deeply integrated, we used the low-level APIs of the engine and integrated that with the brain. So instead of just looking at the top hypothesis that the speech engine produced, we took the whole matrix of recognition and matched that against what the brain knew in terms of what was the current context, what, and what did we already know, and then re-ranked and recalculated what the speech input actually most likely meant. So that was one of the ways. We had a few other tricks that we implemented by deeply integrating the speech engine with the brain. So you really want to do that, the speech engine and the can use the context and the intelligence of the brain. Again, if you have some reasoning ability, is this hypothesis actually, does it make more sense than another hypothesis that the speech engine provides? So yes, there's definitely, it's a different modality that requires, or that can benefit from brain processors. Or
And similarly to speech, so the speech is almost like an additional piece of technology, I suppose, that works alongside the brain.
Correct.
You've got the channels that you mentioned all have their own quirks about them. For example,
Dynamic,
WhatsApp.
yeah.
Someone might send an emoji in WhatsApp, or they might send a picture. So you need to be able to kind of figure out what that means. But then also, let's say you have something running in an app, and maybe part of the input of that is touch. You're in the middle of a conversation and somebody clicks on a link on a website onto another product. The assistant kind of needs to understand that they've clicked on that product and switch the conversation potentially around to that product because now the conversation's moved on, kind of thing. Lots of different inputs is what I'm trying to get to. And so there's omni-channel, which is, concurrent channels at one time or switching from one channel to another, whatever it might be. But you've also got the modality changing as well. I'm wondering if you've thought about, over the next however many years, the future of these interfaces as they become language plus touch plus location plus facial recognition plus. Like, what are your thoughts on that?
Yeah, absolutely. And in fact, we started out our original engine that we developed did have all the modalities. It had vision. In fact, our first prototype was a virtual mouse living in a virtual environment and had whiskers and ears and eyes and
it was ahead of its time. It's that kind of stuff would go down well now in some of the metaverse examples I've been seeing.
Yeah, and then, as I said, when we then moved over to personal assistant, it actually had a browser sense, so it could sense, what was on your browser, and a mouse that it could activate and actually act on that. So yes, ultimately, absolutely, you want those other inputs as well, and we currently do that. So again, going back to 1-800-Flowers. We do use the input of where people are on the website, for that channel. What are they currently looking at, so that when they then ask for help, we have that context and we can use the context. And that kind of additional input, whether it's emotion detection in voice, which is pretty shaky, it still doesn't seem to work really that well. Or even facial emotion detection also isn't nearly as good as some people like you to believe. But one can potentially use all of those inputs and should use whatever information you can to supplement, you know, your senses in the brain, the input that comes in. So absolutely, that's an ongoing part of our development to kind of see what additional inputs can we use to have better cognition.
Mm. Nice, nice. What's exciting you about? We've spoken about a lot today in the course of the conversation. We spoke about large language models. We spoke about kind of like mapping the human brain almost. We spoke about multimodality, omni-channel. We spoke about all kinds of areas. Excuse me, regarding intelligence and stuff like that. What's some of the
Mm.
stuff right now that's really kind of exciting you about this technology and where it's going?
Well, it's really moving forward on IQ and moving up the IQ, and we we do that. And what I'm excited about is to do it in really two parallel paths that work together. The one is the more theoretical development of basically increasing the IQ. And the other one is the practical commercial applications. And they have different dynamics. The moving the IQ forward is always going to be, as you're pushing IQ, it's going to be less reliable. Whereas on the commercial side, you can't afford for the system to make mistakes. So you basically need to put more guardrails around what the system can do. So one example is our system has natural language generation capabilities. You know, you can have a free form conversation, you can tell it stuff about yourself, and you can then ask it about it. We disable that in the commercial applications because legal needs to sign off, marketing needs to sign off, QA needs to sign off on what the system actually says and how it says it. It needs to fit in with what the company's requirements are. But that would be one example. So it's really the challenge to crank up IQ and get closer and closer to human level intelligence. And what I mentioned earlier is I'm really looking forward to the point where it'll require less and less human involvement to teach Aigo new things.
Mm.
That's kind of what our focus in is. As far as the more general AI, what's happening in the AI community is the realization that pure deep learning, machine learning, statistical models aren't good enough for AGI. I think that's nice to see that realization. And so there's going to be an increasing effort in trying to figure out how to give it that reason, how to give it the missing components. Now, I think they pretty much have to throw out what they have. It needs to be a fundamentally different approach. I'm not saying we can't learn from these statistical models, but unless there is a cognitive architecture that constrains what you can. One of the ways of thinking about it, which is not exactly right, but kind of gives you an idea, is these big language models, you can always think them of subconscious processes, or I mentioned like dreaming or stream of consciousness kind of thing, which you can't rely on. It's like if you're on drugs or something. It's just stuff that comes to mind, basically. That's not going to be good enough for intelligence that you can rely on. So you need that cognitive architecture, the reasoning part of it. But if it can leverage the parts that have already been learned with these trillions of parameters that are being trained, if you can somehow manage to do that, that'll be awesome. But that seems pretty hard because these current models are black boxes. And it's very difficult to know how you can actually hook anything into that, APIs or formal ontologies. Now, maybe somebody will figure it out, and maybe we'll figure it out on how to use those big language models in addition to the the reasoning system that you have and the more formal system. Our system is not at all a black box. Everything is completely scrutable. So if the system doesn't give you the right response, you can pinpoint exactly why that is, and you can remedy it. Whereas with big data models, if it doesn't give you the right response, really your only remedy is to give it more training data and rebuild the model, retrain the model, and hope that you don't have catastrophic forgetting on the stuff that used to work before. So you really, from an engineering and reliability point of view and explainability point of view, you really want as scrutable a system as possible and explainable a system as possible. So yeah, it's exciting times to see how we can move, both in terms of what our company is doing, sort of irrespective of what other people are doing, but also seeing in the AI community the realization that you really do need reasoning and real-time learning and some of these other components that I mentioned.
Wicked. That is fantastic. That is really interesting stuff. I really appreciate you joining us, Peter. That's been unbelievable. Definitely learned a hell of a lot there. For those who are listening in, go to aigo.ai for more information. That is aigo.ai. Almost makes the AGI kind of like initials. aigo.ai. Yeah, really sounds interesting. I think that what you're kind of touching on, I love the angle you're coming at it from, which is that the other examples out there, obviously we know the intent-based models, they're just, quick response. If you don't program the brain behind it, which you have to do new every single time you build anything, and you do it very manually and it's all rules-based in terms of the logic, if you don't do any of that, then every single thing that you say to any of it is just completely new information. And the large language models I completely agree as well, which is that they are, just big black boxes that are regurgitating whatever it is that they've been fed, kind of thing. So I love that idea of approaching it from mapping the framework and getting a framework of the brain first, and then applying that thinking logic, the foundations of it all, to certain situations. I think that's really good.
Yeah, I just want to mention I do have a number of articles about various things like free will and cognitive architectures and third wave of AI and AGI and all sorts of different things. They're linked from the website, or you can also find them on medium.com. Peter Voss, my name, but yeah, they're also linked on the website. The other thing you mentioned we didn't get to, you mentioned at the beginning, is about consciousness. Will we have conscious? And I just want to leave you with that any truly intelligent system automatically will be conscious. It has to be.
Right. Interesting. Okay. Any truly intelligent system has to be conscious. So I suppose the question of what is consciousness, we might have to leave for another day.
Right.
Unless you have a short answer for that.
I do have a short answer. It's not going to satisfy everyone because obviously people have had whole careers on consciousness. There's a conferences of 1,000 attendees every other year towards the science of consciousness. So my quick answer is definitely not going to satisfy everyone. But you can kind of take the mysticism out of consciousness, or the mystique out of consciousness, by thinking of it as awareness. And basically, it needs to be self-aware. And once you look at it that way, that it essentially needs to be able to model its own existence and its own thought processes. So it needs to be self-aware. That's really the key of consciousness. And, then how it feels to be conscious and all of that, yes, one can talk about that. But the key part of it is an intelligent system has to be aware of itself as an agent acting in the world, and it has to be aware of its thought processes in some way. So it needs to have the self-awareness, both in terms as an acting agent and as a thinking agent.
Very good. And I suppose the challenge with trying to figure that out is that some of them might talk like they're aware of themselves. Without actually being.
Of course, the Turing test type competitions and so on, people go to a lot of trouble to program hard code systems that will fool the judges into believing that the system is conscious. Yeah,
Mm.
I mean, of course, you can write a 3-line program to, "Are you conscious?" "Yes, I'm conscious." And, um,
Yeah, classic. Mitsuku was one of those. We had Steve a long time ago on the podcast talking about
mm,
Mitsuku. That was quite interesting. Loebner Prize winner, but
mm.
it is all rule based, and he is very open and proud of that fact because it is,
Yeah, no,
and
it's
it works pretty well as well, you know.
amazing how well it can fool judges. Yeah.
Yeah,
Uh, uh,
exactly. Cool. Well, Peter, this has been absolutely fantastic. Thank you so much for joining us. AIGO.ai. I'll put also the links to your Medium articles in the show notes as well. VoiceSummit.ai to find out more information about the event that we're doing in Arlington, Virginia at the Voice Summit in October on October the 11th. Use the promo code VUX20 to save 20% on your tickets, and also VUX.world/Cognigy to register for the webinar that we're doing next week, September the 1st, all about upping your CX maturity. And until the next one, we'll see you again very soon. Peter, thanks.